Solving systems by the equal values method. The equal value method is another way to solve for the solution to a system. And in this method, we'll see equations in this form, y equals mx plus b. You'll notice that both equations in example 1 are in that form. And when that is the case, since x minus 6 is equal to y, and 4x minus 22 is equal to y, since they're both equal to y, or set equal to y, we are allowed to set the expressions that are in the yellow circles equal to each other, since they both equal y. So I'm going to take x minus 6 and set it equal to 4x minus 21. So notice the two expressions that I circled, I simply set them equal to each other, since they're both equal to y. And now I will solve this equation for x. And we've done this before. We want to move the smallest x to the other side of the equation and combine them. So I'm going to subtract x from both sides. So it disappears from this side, and I'm left with negative 6. And then on the right-hand side, 4x minus x is 3x. And then I bring down subtract 21. Now, I still need to keep solving for x, so I'm going to add 21 to both sides. And negative 6 plus 21 is 15, and I bring down the 3x. And then I divide both sides by 3. And that leaves me with x equals 5. So I am halfway finished solving this system of equations. I know that the point of intersection has an x equal to 5. Now to find the y, it's very simple. All I need to do is take the value I found for x and plug it into one of the equations above for the x value. So I'm going to choose to plug it into the top equation. So I'm going to take that 5 and plug it in for the x. So it'd be y equals, instead of x minus 6, I'm going to put the 5 in for the x. And then 5 minus 6 is negative 1. And that is the y value. So I put that with my x of 5, and that is the solution to the system. And if you want, one thing you can do is take that point and plug it into the bottom equation. So the negative 1 is a y. I'll do that right here. So negative 1 is the y, and then the x is a 5. So I plugged both of those values into that bottom equation, and then 4 times 5 is 20, and 20 minus 21 is negative 1. And notice that is true. Negative 1 equals negative 1. So I just showed that negative 5, negative 1 is a solution to the bottom equation. And remember, that's the only point that's a solution to both equations. Okay. Let's try example 2. Again, you're going to take 7x minus 7 and set it equal to negative 3x plus 33. We can do that because both of those expressions are equal to y, according to these equations. So 7x minus 7 equals negative 3x plus 33. Again, I'm going to solve for solve for x. So I'm going to move the x's together by moving the smallest x first. And remember, the reason for that is we'd like to keep the x positive if possible. I think it makes it an easier equation to solve. So 7x plus 3x would be 10x. We bring down the negative 7, and I have 33 on the right. Now I'm just going to add 7 to both sides. So I bring down the 10x, and 33 plus 7 is 40. And then I'm going to divide both sides by 10. Remember, we're solving for x here. So I get x equals 4. So I'm halfway home. Again, I have found half the answer. I know the x value of the point of intersection is 4. And now I can take that x and plug it into either equation for x, and then I just solve for y. So I think I'm going to plug it into the top one again. It's your choice. I like the fact that the top equation It's positive 7 times x, where the bottom equation is negative 3 times x. I think it might be easier to deal with positive numbers if we can. So I'm going to plug that 4 into the top equation. So the equation would be y equals, instead of 7 times x, it's going to be 7 times 4, and then subtract 7. 7 times 4 is 28, and 28 minus 7 is 21. So I just found out that my point of intersection for the y is 21. So 421 is the solution to this system. That is the one point that works in both equations. Now, in example 3, again, I do the same thing. I take 2x plus 4 and set it equal to 2x minus 5. And I'm going to move the smallest x to the other side to solve for x. Both of these are the same, so I'm just going to move this one over by subtracting 2x. And notice that 2x minus 2x actually cancels out here, and 2x minus 2x actually cancels out here. So I'm left with 4 equals negative 5. So one thing you might ask yourself is that true? Does 4 equal negative 5? Well, of course it's not true. So when that ends up being the case, where you get an expression that's not true, that means there is no solution to the system. And remember, when it's no solution, that means that the lines were parallel. And we can hope some of you might have noticed, just from looking at the equation, notice that the slopes are both 2. Okay, parallel lines have the same slope. Okay, so when you end up with a line where the two slopes are the same, there's a good chance they're parallel, as long as they have different y-intercepts. For the last example over here, example 4, again, I'm going to set 3x plus 5 equal to 3x plus 5. Some of you have probably noticed already that those are identical expressions. Okay, these two equations are exactly the same. So what happens when I solve using the equal value method? Well, I would move the x's together by subtracting 3x. Of course, that cancels. And I'm left with 5 equals 5. Well, that's true, right? 5 does equal 5. So that simply tells us that these two equations are identical, which means that there is infinite solutions. Remember, this is the situation where if I were to graph these two lines, they were both going to be in exactly the same spot. So every point that works in the top equation will work in the bottom equation. So we'd say we have infinite solutions.